For Krea 2 model, it seems everybody is saying you should use the WAN 2.1 VAE so you can get a better image result. Let's run some simple tests to see whether that's actually true. I'll build a very simple workflow for the comparison. Let's start by adding the image previews, which will serve as our final output viewer. Right before that will be the VAE decode node to decode the calculation result into an image. And before that, we will load the VAE models that we will compare. The official decoder is the Qwen image VAE, and the everybody recommended model we are comparing is the WAN 2.1 VAE. We will use one K-sampler for both pipelines so all other parameters are the same. Since we're running the turbo model, we only need 8 steps here, and the CFG value should be set to 1. Here is where we can start loading our Krea 2 model. We'll use a load diffusion model node and connect it to the K-sampler. And let's choose Krea 2. Next, we'll need our text prompt box. Now, because this is a turbo model, we already set the CFG value to 1, which means the negative prompt is going to be ignored. So you can simply just connect it to the negative prompt input of the K-sampler. In professional workflows and official templates, however, they all use this conditioning zero out node for the negative prompt input. So let's also test that out with a secondary branch to see if the conditioning zero out node would make a difference. Let's copy the following parts from the first row here and then connect the output from the K-sampler. Let's also add some comparison nodes so we can see the difference side by side. Notice this node shows input A by default and shows input B when you hover the mouse cursor at the right side. Let's name this node VAE comparison. So, this section is for comparing the VAE decoders. Let's color code them so everything stays clean. And over here, let me do the same for the conditioning zero out node comparison. Okay, now let's get back to where we left at the prompt box node. We also need a clip model so it can read our prompt text. Here for the Krea 2 model, we need to choose Qwen 3VL4B and also need to change its type to Krea 2. To ensure a completely identical test, we will use the exact same seed. So let's search for a seed node. This CR node will do. We'll use its output to connect to both K-samplers. I like to keep the sequential order clear. Let me put this node to the left side so we can get a better look at the processing order. At last, we also need an empty latent for both K-samplers. So as you can see, we now have the same latent, same seed, and same prompt. Let me color group these same parameters for easy understanding. And as before, I will move these initial parameter nodes to the left side, so the order looks clean. Now that the workflow is set up, let's get some random prompts. I'll just Google random images, feed the screenshot to Gemini, and ask it to generate image description as our prompts. Here, let's copy-paste this first prompt to our workflow and hit run. Oops, I did not connect the model for our second K-sampler. Let's fix it and run again. I was wondering why that generation felt so fast. It's because it was running on the default 512 by 512 latent resolution. That's a bit too low for a detail comparison, so let's bump it up to 1344 by 1344. That'll give us better image quality while keeping the render times reasonable. Alright, we've got our first text-to-image output. Let's look at the VAE differences first. Let's zoom in a bit more so you can judge whether there is any difference. It seems there is a tiny bit of difference in the fur texture on the sloth. Let's zoom in onto the floating food. You can see with the WAN 2.1 VAE decoder, the texture has a bit more noise, especially for the fillings inside this burrito. I feel adding more noise doesn't make those vegetables and meat look more natural and delicious. They feel a bit weird with those extra noise. However, looking closely at the wrap, the WAN 2.1 model's extra noise seems to make the surface just a bit more realistic. But the difference isn't really that much. I'm sure if you don't zoom into the extreme and compare them side by side, you wouldn't be able to notice a difference. For the pizza part, well, I would say I'd prefer the default Qwen image VAE rendering. It's more natural and clean. The WAN 2.1 VAE rendering, on the other hand, looks too dirty, with all those little spots that make the food look ill or have gone bad. I'm sure if you use an upscaler to upscale that WAN 2.1 VAE output, those horrible spots would only grow more obvious and look even more horrible. But that's only my personal opinion. Now, let's move downward to compare with the conditioning zero out node's output. Let's zoom in and have a good look at the detail. I think I see no difference at all. In fact, I've tested this before, and I am pretty sure the conditioning zero out node does nothing in turbo model workflows. All right, let's test with another prompt. Let me try to find something a bit complicated so we can get a tricky prompt. Here, how about this one? This image grid. All right, we've got our prompt, and let's hit run again. So this time we've got 5 different pictures within one photo grid. Let's zoom in on the fox illustration first. Still, I find the difference between these two VAE decoders is negligible at best. If I have to point out the difference, the fur curve on the chin is slightly altered, and the eyeball texture is a tiny bit different. This could be counted as meaningless difference, I suppose. As for other parts, I really can't see any difference. All right, moving over to the top right image here, we can see a tiny texture difference around the door frame and the lock. The WAN 2.1 VAE does add a bit more detail and contrast, giving the surface material just a bit more definition here. Zooming into the cartoon cola, the WAN 2.1 VAE introduces a lot of weird noise into the liquid texture, making it look like dried up resin. If I am offered to choose between the two, it's no contest. I'm definitely grabbing the one rendered by the Qwen image VAE. Looking at the fur on its arm, the WAN 2.1 VAE manages to pull out a bit more detail by bumping up the noise and contrast. So if you're rendering fluffy fur, this decoder is going to make those textures look as if they are sharper. As for the part where the texture is smooth, the rendering from the two decoders is barely different. Let's get our final generation prompt. I'll randomly choose this vintage photo as our sample image. Let's paste the prompt and run. Now, if you look really closely around this woman's eyelids, the noise added by the WAN 2.1 VAE actually makes the photo look unnatural. It suddenly starts looking like a low-res AI render. On the other hand, the Qwen VAE gives us a much cleaner result. It might not be very sharp, but it just looks more natural. And we're seeing the same problem with the other characters too. If we zoom into the cards, the rendering on the words is visibly different. Both decoders just generate different flavors of gibberish, and neither one is readable at all. The WAN 2.1 VAE output looks slightly crisper, but it's still completely unreadable. It's honestly just different noise patterns. Once again, let's examine the conditioning zero out node's output. And the result is like what we've seen before. It does not make any impact to the output at all. So, based on the above comparison tests, we can draw the following conclusion. First, the conditioning zero out node is completely unnecessary for turbo model workflows because the negative prompt is bypassed at CFG1. Second, when it comes to the decoders, the WAN 2.1 VAE simply pushes more artificial noise and contrast into the image rather than making it genuinely clearer. The official recommended Krea 2 VAE is already incredibly capable, delivering natural textures without any strange artifacts or messy noise. So that wraps up our comparison workflow. If you find this video helpful, please give it a like. I will share the workflow through my Google Drive and put the link in the description below.